Hello and welcome to another edition of TGI Kubernetes. My name is Joe Beda and I am your host for today. TGI Kubernetes is a weekly-ish live stream where I go through some of what's going on in the Kubernetes world and do a deep dive into some type of topic. Vary it up every time. A lot of times, recently it's been covering some interesting projects in the community, stuff building on top of Kubernetes. So I'm the CTO of Heptio, one of the co-founders. We're a company helping bring Kubernetes to the enterprise and beyond. Before that, I was at Google and helped start the Kubernetes project. So I like to start out by, first of all, doing a sound check, making sure that I look fine, I sound fine, because you never know with these things if everything's going to be great, but hopefully things sound good. I want to say hi to everybody on the live chat over on the right there. So when I first started doing these streams, there was no way to capture the live chat, and so I had to do some hackerama with OBS to be able to redirect the live chat onto the screen. But then recently I saw that YouTube will actually sort of, replay the live chat in time right next to the video when you're watching it after the fact, when you're watching a recording. But I still like having the chat there because for folks who are watching this perhaps on a TV or what have you, you don't always see the chat along with it. So it is part of the interactive nature of stuff. So yeah, so let me say hi to everybody. So starting from the top, Enrique from Spain, and I just love that everybody's joining me from all over the world. It's 1 p.m. here on the west coast of the U.S., but a lot of folks, it's their Friday evening, so thank you for joining me on your Friday evening, and for some folks, like they like to say, they're living in the future, and it's already Saturday morning. So thanks for spending some of your off hours with me. Okay, so Enrique, Sean, Lamadi, good to see you. Parthaman, let's see, Suresh in Hamburg, Keith in Scotland, Sen in DC, I'm butchering your name, I'm sorry, from Cork. Let's see, Philip. Good to see you. Steve, who's a Heptio employee, he's actually one of the main author of the project that we're going to be looking at today. So thanks for joining us, Steve, and helping us out. Ayush, Kris. So yeah, let's see. All right, so sound and video looking good. That's good. And yeah, so let me go through. Oh, and Ryan's able to join us too. So Ryan is our lead trainer here. At Heptio, but before that he was at Elastic, and so he has a lot of very deep knowledge on Elastic and the Elastic stack there. So I'm glad that Sean was going to be on, Ryan was going to be on a plane. I'm glad he was able to join us. And now it's 1:30 a.m. Oh my goodness, man! That's and then Ravi from India. All right. Well, let's go ahead and get started. Thank you, everybody. The main topic that we're going to cover today is going to be the Elasticsearch operator. I'll go into some details in terms of what I understand Elasticsearch to be for those who aren't super familiar with it. I'm kind of an Elasticsearch noob, but I did spend a lot of time at Google, so the whole search space is something that I actually have a decent handle on. And then I'll also talk about what an operator is and how that fits in with Kubernetes, and we'll go through some of the nitty-gritty details of using the Elasticsearch operator. I think it's a good example to sort of view this lens. But a lot of times I like to start TGIK by going through some interesting stuff that's been going around the Kubernetes community. So let me go ahead and switch to my screen, and we can start. So the first one, you guys probably saw my shirt here. I'll switch back to my face here. So this is a shirt that this drawing was made by Ashley McNamara. Now she's developer advocate over at Microsoft, and she, as a hobby, does a bunch of illustrations all over the place. So she took a bunch of her drawings, and she actually put them up to be made into T-shirts with the proceeds helping women who go. And so I ordered one of these a little while ago. And apparently this was, as a little while ago, they had raised like $5,000, but I'm sure it's more than that. There's a ton of designs there. She originally went with one vendor and then switched it up. So now there's a threadless store here And if I click on this, you can see like there's like, you can just do like load more. It's like so many cool shirts. And so I got this one, and then my son, we got him like the video game playing one. I don't know if we can find it here. It's in here somewhere. So yeah, there's the this is fine. There's the gophers hugging, which how do they hug? I don't know. They bump eyeballs. The gopher mic drop is awesome. Yeah, the gopher pride. And let's see if I can find, I don't see the video game playing one that my son, there's like a sailor one, maybe that's, I don't know if that's a Kubernetes specific sailor or not. So yeah, so a lot of great things there. And so, you know, shout out to Ashley. Now Ashley was recently, there's a Kubernetes gopher shirt. I should get that at some point. So Ashley was recently in the hospital and had some surgery. And yeah, gopher. No, but the thing said gopher, Kris. So, you know, I go for pride. But Ashley was in the hospital. She's out now. She had some surgery. And so I just want to send positive thoughts her way on a speedy recovery. So, yeah, and thank you for doing these for the Women Who Go Diversity Scholarship. That's a really cool thing that you did there, Ashley. All right, so let me go through. So other stuff I wanted to pull out. So like for TGIK, sometimes I'll pick a topic and I'll go through a series. That's what we were doing before. Sometimes it's more sort of, ad hoc. A little while ago, I sent out a survey, and like top of the list here was the Elasticsearch stuff. So that's what we're doing right now. But the whole idea of WeFlux and this, the whole idea of GitOps and sort of WeFlux as one implementation or one tool for that was also very, very popular. So I'm hoping to do that soon also. And then a little while ago, I did a live coding of a controller. I'd like to do something like that again, and something that I've been kicking around for a long time is building a Minecraft server operator where we can build an operator, it launches Minecraft servers, and then we can look at what does it take to actually manage full lifecycle of those services, how do we deal with the networking issues for these things, how do we go through and then also manage maybe doing a GUI on top of it, that type of thing. So I think that might be fun as a sort of multi-part project that has the potential of being a huge amount of time that I'm signing up for, but I think that one would be fun too. So keep your eyes out for future topics there. Let's see, other stuff that I did is on Wednesday, I did a talk at DevOps Days here in Seattle, and talking a lot about sort of extensibility of Kubernetes. And so the talk was Kubernetes as a platform. I went ahead and posted my notes, my slides with speaker notes. And so I tend to write relatively complete speaker notes when I do these things. And so I'll go ahead and include this link in the show notes afterwards so that you all can see that. So Lamatti's asking, is there any plans to dive into the Cilium in the future? I'd like to. I want to figure out how to get a handle on it. I mean, networking is a tricky thing to really dive into. But I don't feel like I'm an expert in that particular networking implementation. And it starts to cross a bunch of lines, which I think is really fascinating. One of the things that I did want to call out, and I forgot to put a note in here, is that these folks hit 1.0 recently, if you go and look at the blog. And so I'll go ahead, and this looks super exciting. So it is on my list in terms of things that I want to start really understanding and digging into. So I'm gonna make sure that I include that link in the show notes also, because that was something interesting that happened this last week. And I know Jesse Frizzell is also a huge fan of them, and it starts looking at using something that's more efficient and sort of more purpose-built for doing some of the stuff that Kubernetes does versus IP tables. Like if you look at something like IP tables and the way that we do cluster IPs, it's kind of strange. And so I'm really interested to understand more about what these folks are doing. All right, so the other big news for us, at least this week, is that we introduced this project called Heptio Gimbal. Now this builds on top of Contour, which we've covered in a previous episode of TGI Kubernetes, and it also built on top of Envoy. And the idea here is that we want to take the ideas behind Ingress and we want to move it forward in a, in the Ingress system, which I've also done a TGIK about, and we want to move it forward in some significant ways. And we did this as a joint effort between us and one of our customers, Octopio. They used to be known as Yahoo Japan America, so they are essentially an American subsidiary of Yahoo Japan. Yahoo Japan, even though they share a name with the US Yahoo, which is now Oath. This is very confusing. You have to draw a map here. It's really a very different company, and they really have a very different position in the market in Japan than Yahoo in the US. And so, but one of their problems that they had is that they were looking for a more holistic load balancing ingress infrastructure, not just for a single Kubernetes cluster, but across Kubernetes clusters, and then also for some of the other technologies that they're running in production, including OpenStack. And so they were looking for something that could help them define an ingress-like experience across OpenStack and Kubernetes, and then shift load back and forth between these things. So it's still very much focused on solving what we call the north-south, the incoming load balancing thing, versus east-west, which is sort of service to service. So still focused on the north-south, but instead of thinking of the load balancing infrastructure as being part of a cluster, we're thinking about extracting that to be a separate component, a separate control plane. Now, under the covers, it uses Kubernetes and it uses the extensibility points, but the goal there is to provide, a scalable software-based load balancing control plane. Now, along the way, one of the things that we're doing is we're proposing and going to be implementing in Contour some new alternatives to the ingress data schemas that are more attuned towards multi-team scenarios. Because right now, when you're running ingress in a cluster, if somebody writes an ingress rule, they can pretty much squat on anything, any part of the URL space that you'd like. One of the things that we're looking at is a way that you can have a permission delegation model where you can say, hey, I want this particular namespace to be able to handle this host name or this host name, anything under this particular path. So if you go in, I'm going to include this blog post again in the show notes, but if you go and you look down here, there's, we also added, so we're going to look at overlay networks. Where was this? I think there's a proposal, new design for the policy stuff here. So this is something that I've been working with Dave Cheney and other folks working on Gimbal. Steve is actually Steve Slocum's here, is one of the folks who's been working hard on the Gimbal effort too. So Lamatti says, Gimbal looks crazy awesome. Did you see it one day working across clusters at different cloud providers? Yes and no. I think any time where you move from being to a single node to a cluster, or from one cluster to multiple clusters, or from a set of co-located clusters to a set of geographically located clusters, there's really new considerations you have to take into account. I could see over time us adding capabilities that work to distribute traffic across different geolocations. To really do that well, though, you need a deep level of networking support that's difficult to do with clouds. Now, you can look at doing something like Backplane, which is a commercial competitor that essentially does some of that geo-based distribution. They have to run a bunch of their own infrastructure that really sits outside of clouds, and the way that you hook up to Backplane, I think, is it's kind of interesting and novel. In my mind, there's a question in terms of how applicable is that to a lot of companies in terms of the way that they think about managing their networks and their infrastructure. Google, GCP, Google Cloud Platform, does have some really interesting capabilities for doing cross-region load balancing in a super smart way. And I think they're relatively unique there. They use this technology called Anycast IPs, so that you essentially get one global IP address that smartly routes to the regions, the clusters where you have capability and capacity. So it's a really complicated thing. We want to start doing something in that direction, but baby steps, one thing at a time. And then let's see, before that, Saeed said, voted for Flux, bummed that it didn't get, so yeah, maybe, well, next week is going to be Kubecon, so I'm not going to be doing a TGIK because I'll be, it's hard enough to do it here, let alone doing it, when traveling, but definitely going to be looking at maybe doing Flux the week after. All right, so let me keep moving here. So there's also, this is fascinating, there's a new branding for Go, the language, which is, I think everybody's kind of scratching their head on this. It's I'm not quite sure what to think. So there's a ton of hot takes. So it was Steve that essentially at least wrote the blog post. Enormous amount of respect for Steve. Steve did such things. You might know him from Hugo. He wrote the Hugo the Hugo static site generator. He also did Cobra, which is the command line framework. He did the P-flag stuff. So he's done a whole bunch of interesting Go projects. He's now at Google doing this stuff. And I assume maybe he led the rebranding effort, but it's fascinating. But everybody's really worried. But like this line here, the beloved Gopher mascot remains a central part of the brand. But when you download the brand book, it's not clear that that's the case. So we're still figuring that out. My favorite thing about Cobra, Kris is like, I love Cobra. My favorite thing about Cobra is that it's actually Cobra Commander, which is a total like old school G.I. Joe reference, which, harkens back to my youth. So, hey, Bob from Bellevue. Thanks for joining us. All right, and then let's see. And then next week is KubeCon EU. It's in Copenhagen. I'm going to be leaving on Sunday, traveling there, going to be all week. A lot of interesting talks going on, a lot of interesting stuff. I'm not speaking this time around, but we do have a lot of Heptio folks that are going to be there. We're doing a paid training if most of the folks that are dialing into TGIK are already pretty far down the Kubernetes path. But if you're new, there's still some slots available there. Ryan is leading that up, and he's on the line here for TGIK. And then we're talking about Contour. Craig Tracy, one of our field engineers, is talking about sort of day 2 things. Kris was going to be doing a talk with Jesse Frizzell, but Jesse had a conflict and can't be there. And so that session might change. They were going to do like Jesse and Kris hack each other. And I'm super disappointed that they won't do that. So I'm hoping that maybe some other time they can do Jesse and Kris hack each other. Let's see. So Kate, one of our UX engineers, is going to be talking about building applications on top of Kubernetes. Brian's going to be doing a talk on K-Sonnet. Andy's going to be talking about Arc and migrating stuff and treating clusters as cattle. Let's see, there's a panel from George looking at sort of office hours. We're going to be doing a live office hours. Let's see, K-Sonnet plus Arc plus Sonaboy plus Kubeflow. So Kris and David Aronchik from Google are doing a big mashup talk. Deep dive on SIG cluster lifecycle, where we're putting a lot of effort in these days. This is Kubeadmin and friends. And then finally, there's an Envoy deep dive where there's some like lightning talks, and Ross, who's been one of the folks working on Gimbal, will be talking there also. So we have a pretty full schedule here. Oh, and then the other thing is that there is a diversity luncheon panel. We're gonna have to put that on this gist here, Kris. But there's a diversity luncheon panel with Shanice, who's our VP of Operations and Finance, who's going to be going to KubeCon also, and Kris will be talking, and Heptio is co-sponsoring the luncheon there, so that should be super interesting. Let's see. And Sean says uses Hugo and can't not use Cobra and Viper. Yeah, exactly. So Steve's pretty prolific there. So yeah, so if you're at KubeCon, and we're also going to have a booth, so come by and see us. So okay, end of pitch there. And then KubeCon is going to be Wednesday, Thursday, Friday. The Tuesday before KubeCon is going to be the Kubernetes Contributor Summit, which George has been, and Paris, who's another community manager working at Google on Kubernetes project, have been spending a ton of time planning this. The morning is focused on, there's a lot of work on sort of new contributor workshop, and sort of like there's some tracks around doc sprints and stuff like that, getting some work done, but also providing an on-ramp for folks who want to contribute, who need some help to be able to get going. And then there's going to be some SIG updates and some stuff going on after that particular day. So this is going to be the day before the conference is probably my fullest day, because we're doing our training then. We have this contributor summit, and then there's a bunch of CNCF activities also. So, everything's going to be a letdown after that. All right, so that is Holy moly. So I covered a lot of sort of pre-things. I think, there's a lot of announcements oftentimes going into KubeCons. So I think we see that there. But I want to get down to the meat of this and start looking at the Elasticsearch operator. Any last questions before we start digging into stuff? No? I'm watching the chat here. I'm going to open my Diet Coke. I'll do like the frog thing. So Ryan says, no sleep till Brooklyn. To Brooklyn. It's till Brooklyn, Ryan. Get your Beastie Boy references right. Let's see. So Enrique says, this week started the beta testing of the new CKAD certification. I completed the exam just a couple of hours ago, and it looked pretty ready and definitively worthwhile for developers and Kates. Yeah, so yeah, thanks for mentioning that, Enrique. This is interesting. There's the new, so right now there's a certification exam for the Certified Kubernetes Administrator exam, which is really about running a cluster, getting it up and running. There's a new exam that's being developed, which is aimed at application developers, which is really about what does it take to write and run stuff on top of Kubernetes in an effective way. And I love the ability to the fact that like some of those certifications actually do recognize that split between running a cluster versus using a cluster. And I think that over time we're going to see more and more of specialization across those two different dimensions, and even further than that. All right, so let's get down to brass tacks here. So the Elasticsearch operator. So this is something that Steve did at his previous employer, and they actually had to use the thing, which means that it probably works because you write software differently when you're actually using it yourself, which I find incredibly encouraging. And basically the idea is that it provides an API-driven way to launch and manage Elasticsearch on top of Kubernetes. And so for those who are not sort of like, don't have the decoder ring, an operator is a special type of program that runs on top of Kubernetes that listens to an API using some of the Kubernetes extension points, and we'll see how that works as we go through this, and then turns around and talks back to Kubernetes to launch lower level, more primitive objects to actually accomplish a task. And so it's a domain specific capability, the domain in this case being Elasticsearch, that reuses and sort of feels natural on top of Kubernetes. Along the way, because it's using the Kubernetes extension points, you get a lot of the benefits around authentication, authorization, auditing, all the other stuff that's sort of, that ecosystem of stuff being built on top of Kubernetes. So that's the operator pattern. Elasticsearch itself is a horizontally scalable full-text search engine. The idea being that you take documents, everything in Elasticsearch is a document. You submit a document to Elasticsearch. It has a bunch of pluggable, extensible, ways of analyzing that document, and then it indexes and stores the document. And so you can do search over that, and then it can return the document to you. This is used in a whole bunch of different contexts. It can be used for taking all the content of your site, putting in there, providing a search capability there. It can be used for product search. It can be used for, I'm not sure what exactly Steve was using at the previous employer, but it could be used for searching medical records. I don't know if it's HIPAA compliant or not. So there's all sorts of things. One of the common places in the Kubernetes world that we see Elasticsearch used is with log data. So you'll take log data. If there's some structure to it, you can use a specialized parser to tokenize that structure out, and then you can search through your logs and then view them either in a time-based way or by searching. So Ryan, who has taught on this stuff, so he is the expert. He says Elasticsearch is a software layer data replication distributed system and falls into the category of Cassandra, MongoDB, etc. There are special considerations when you start, shut down, and move instances from one machine to another. So yeah, so log, and Steve says it is HIPAA compliant. That's the reason why they built, so the AWS version wasn't. So that's good to know. And then Enrique is saying is that even Uber uses Elasticsearch as a real-time database. So a lot of times when people think about Elasticsearch and Kubernetes, they're thinking about it from that infrastructure point of view of ingesting and managing logs. But I think it's also interesting to recognize that this oftentimes becomes a key part of building a key part of building an application. It becomes a service that you depend upon in an application architecture. So Steve says that they index patient documents for a big data platform. So yeah. Now under the covers, it uses a indexing engine that's been around for a while, indexing and storage engine called Lucene. But Lucene, I believe, is single node, and the big value add that Elasticsearch adds on top of it is being able to scale across nodes, which means that because we're talking about multiple nodes, it becomes a really natural fit for something that can help manage things across multiple nodes like Kubernetes. All right, so does that, hopefully that tees it up here. If folks have questions, feel free to put them in the chat there. There's a demo that Steve recorded here, but I think it's a little bit old, so we're not gonna, I started watching it before this. One of the things to keep in mind is that the Elasticsearch operator makes some assumptions in terms of the cluster that you're running on. So the first assumption is that you can use stateful sets. And so stateful sets, I believe we did, I don't know if we did an episode on stateful sets, but we definitely saw stateful sets in the context of CockroachDB a couple of episodes ago. But stateful sets are a way to manage Kubernetes pods that get paired up one-to-one with persistent volumes. Typically, folks will use these things with with cloud volume. So it's essentially, hey, let's, for each of the data nodes in the Elasticsearch cluster, you'll create and have Kubernetes help manage an EBS volume on AWS with you. So, over time there's going to be, and this is something that's still relatively new in 1.9 and 1.10, there's this idea of a local persistent volume. And it doesn't have an auto provisioner yet, but I think that's going to be an interesting choice with systems like this, especially since Elasticsearch has its own idea around replication. And one of the things that Steve built in here was some relatively up-to-date and relatively sophisticated automatic backup. So yeah. So let's see, and so Sen is saying that local storage with stateful set is such a hit. Yeah, totally. And I think especially when the big place where that local storage stuff really comes into play is when you're running something like on cloud and you have local SSDs, local flash. Even someplace like Google, where they really have some of the fastest networks at sort of large scale. They have a huge investment in terms of building some fundamental technology around SSDs and flash. Even for them, you're just not going to see the latency and the throughput and the IOPS when you're trying to access flash across the network. And so, so what you'll see is that folks that are running big databases, whether it be something like Elasticsearch or Cassandra or whatever, they'll a lot of times, will use the local disk running on a node, the local SSD running on a node. All right, so the other thing that Steve built into here was automatic snapshotting to S3. The way that the operator authenticates to S3 is an interesting thing that we'll go into some detail about. When we first roll this out, what we're going to do is we're going to turn that off. And then if we have time, we can look at turning it back on and trying to get it to work. If not, I'll at least speak to some of the issues and some of the complexities there and what this means with respect to some holes in terms of some Kubernetes capabilities and how those are looking to get filled. All right. So I think we're ready to make some progress here. So as part of this, there is a one and only one custom resource definition. I think as people get more comfortable with operators, we may see these things break up into being multiple CRDs. The MySQL operator, for example, has 4 CRDs. It has the MySQL cluster, it has the MySQL backup, it has a backup schedule, and then it has a restore, right? So, and some of those things, the backupping and the backup schedule are built into the single CRD here with the Elasticsearch operator. So let's see if we can get this stuff going. It does a bunch of stuff around managing search for you. There's ways that you can put stuff in there. There's it uses the images by default. There's the UPMC Enterprises image is I guess the one that we're going to be using by default here. And then there's instructions on how to go ahead and deploy this and get going. Let's see. In another window, I'm going to do this. A lot of times whenever you see these CRDs, and we don't have a great track record in the Kubernetes world of getting great documentation around the schema of YAML files. Most of the time what we find is that you'll see something like this, which is great, but it's easy for a README like this to get out of date of what's really going on. What I usually do is I usually try and find the ground truth in the code here. And so if we go through and if we find this document here, this is the actual Go data structures that store the stuff that we're going to be using for the CRD. So I just want to have, I just want to have that up here as we go ahead and start in case we need to refer to it. All right, so the first thing we need to do is we need to deploy the operator. And I am not a huge fan of just sort of like doing a kube control create directly like this. I always want to look under the covers to see what's going on. I feel the same way about Helm charts. I want to understand what the Helm chart's going to be actually doing before I go ahead and execute it. So to get started, so Steve's saying can deploy from the examples folder. So that's what I'm going to do. So I'm going to do a git clone of this. I missed. I thought I grabbed it. Clone or download, copy. Boom. All right, so we're going to clone this. And then we'll just bring it up in VS Code. So I'm still a fan. I was a couple episodes ago. I was using Golang. I'm still a fan of Golang when you're really writing a lot of Go code. But I find it's just it expects that it has this sort of overarching sort of project model. And so if you're doing sort of ad hoc exploit, because you bring up VS Code, you point it at a directory, and it's kind of like a combination of code editor plus sort of like Mac Finder, and it's very lightweight that way. Whereas Golang just doesn't have that same type of feel to it. All right, so if we look at the examples directory, what we have here is here's the controller itself. And we'll look to see what we're doing. So the first thing we're doing is, and the instructions that, that Steve had here, if I look at this, is that you create the namespace explicitly, and then you specify the namespace when you're deploying the operator. And so Matthias is saying he's using Golang and code the same way too, yeah. Okay, so we have a service account. So some of this is RBAC-iness. And then there's a cluster role for this. And what we're seeing here is that we're allowing the service account to manage deployments, replica sets, and daemon sets, to manage custom resource definitions, to manage storage classes, which seems like, I don't know why you'd need to create storage, to create or delete them. That's going to be interesting. Let's see, and then, manage secrets and everything else across everything. So at this point, this is pretty much this is pretty much root on the cluster that we're giving this thing. I think there might be some ways to slim this down. The place where things usually get hairy with these things, and I think it's something that we need to find better ways to work with RBAC, is that as soon as you give somebody read access across your cluster for secrets, it's pretty much game over, because there's a good chance that they can get access to service account tokens. So it's pretty much root. Okay, so Steve's saying that if you have multi-AZ clusters, it creates storage classes across zones because EBS can only live one per AZ. Okay, so that's interesting. Yeah, and I think the story around EBS and AZs is an evolving one. I don't have a ton of experience with that recently, so yeah. Um, okay, so this is pretty much root, but the interesting thing here is that you can also see that the API group for Elasticsearch and the resource here, it has permissions to go ahead and manage that, which is great. Okay, and then we're going through and we are doing the role binding. And this is one of those places where the subject and so this is a cluster role binding, and the operator namespace here gets hard coded into the role binding, and this is not overridden with the namespace flag on kube control. So if you wanted to change which namespace you were deploying this to, you'd have to go through and actually change this namespace here in the RBAC rule. And this is stuff like this ends up being one of the main drivers for some solution around templating for Kubernetes resources. And then there's a deployment. There's the version 0.0.12. That's a pretty early version, man. Don't commit yourself, Steve. And then passing in the namespace. So this is the downward API, and then there's a liveness and readiness probe. So it's all pretty plain Jane from there. And then well, I'm glad that you're getting something out of it. All right, so let's go ahead and make this thing happen. So I have let me go ahead, kube control get nodes. I have a 3-node, 1 control plane node cluster, and then I can do kube control get version, maybe, and I'm running version, there we go. And I'm running a 195 cluster, and my kube control is 110, because the 110 one has some really cool additions to the port forward command, which I am super duper excited about. All right, so let's get going. So we can go ahead and create the namespace. And then if I cd to the Elasticsearch operator, examples, and do kube control, apply-f controller.yaml.n operator. All right, and so that created the service account, the cluster role, the role binding, and the extension. The deployment for the operator. And now, if we go kube control, if we get the pods, we can see this thing is up and running. Or no, it's not running. It's not ready yet. It's still sort of coming up. But get pods. And if I do, let's do, if I do logs for this, it says it's creating the missing CRD. So one of the things that this thing does as it starts up is it creates the CRD. It registers that new type with the Kubernetes control plane. And in my mind, there's this question, and there's two patterns for how people do this. So one thing is to have the operator self-register, like what happened here. The other way to go ahead and think about this is to say, well, registering and managing CRDs is an admin thing, and that requires extended permissions above and beyond the permissions that we give to a particular operator. And so with that in mind, maybe there should be a separate step as part of that sort of installing the operator. Maybe we should also be creating the CRD definitions then, registering the CRDs. But it looks like you probably do either way with this, since it only registers the CRDs when they're missing. I wonder if it barfs if you don't give it that permission. So this is up and running. So I can do kube control get CRDs. Custom resource definitions. There we go. And that's the custom resource definition that it registered. And you can see that this thing, all you get is it's essentially identifying the names for this thing. It's an Elasticsearch cluster. There's the name of the kind, the list. You call it Elasticsearch clusters. That's the plural. And then the idea is that this is namespace, so it sits under a namespace versus being global, cluster-wide, where it would sit at the cluster level. In newer versions of Kubernetes, and this is something that I haven't explored to the fullest extent, there's been some work going on in terms of providing more capabilities into the custom resource definitions. And so I believe that there are ways now that you can have Kubernetes enforce a schema on these things. And there are proposals and perhaps even some work being done around being able to manage multiple versions of these. Because right now, if you want to do a version upgrade of these, it becomes a client-side management thing. Yeah, so very cool. Okay, so the version stuff is not fully supported in the same way that native resources are. Okay, so we got that running. Now let's create us a cluster. And the example that we're using here is the example ES cluster. So we have a whole bunch here. So we have one with Azure, one with Rook, one with host paths, and then there's the example cluster itself. So let's just go ahead and do the simple example cluster. Oh, I can't see what's going on here. There we go. It's hard to read, hard for you all to read. Sorry about that. All right, so we're bringing up an ES cluster. It's also going to bring up Kibana and Cerebro. It's the admin interface for this thing. For Elasticsearch. It's using what looks like some level of, because this is fascinating, it's using an upstream or a Kibana image provided by Elastic. And they're apparently hosting their own Docker image registry, white labeling that, or probably running their own infrastructure. I'd be interested to know what they're using to do that. And then the Elasticsearch image that we're using is here. And then 3 client nodes, 2 master nodes, and 3 data nodes. So this is a fairly beefy cluster as far as these things go. So I did a little bit of reading, and Ryan and Steve, correct me if I'm wrong. These are all going to be running the same image, but there's some options that you can turn on and off with these things. So if a node is playing as a master in the Elasticsearch, then that means it's essentially a cluster coordinator. It is distributes state in terms of which of the data nodes are taking on which parts of the index space. The client nodes are the things, the data nodes are the things that are actually storing the data. They're the ones that we're going to create EBS volumes to pair with. And then the client nodes are the things that users go ahead and talk to that essentially become smart proxies so that they can distribute requests to all of the appropriate data nodes and then collect and integrate the results together. For smaller clusters, you can collapse these things together, but my understanding is that for production clusters, you really want to make sure that you separate these things a little bit. So let's see. So Enrique says the big challenge with ES is as a stateful setting, Kubernetes is about storage. What's your take on this, Joe? You have to have some persistent storage for these things, is my understanding. It would be interesting, I think, to come up with a solution here, and I don't know how possible this is, that does the whole sort of, doing replicas, juggling, re-replicating, when bringing things up, going and looking at the backups and grabbing the most recent backup, doing a graceful shutdown when you're bringing things down to actually write to the backup so that it could be totally run off of empty, scratched volumes. I don't think that that's supported with this operator, and I don't know how practical that is to automate with Elasticsearch in general. Using emptied or so if you use host path, then you essentially pin your nodes to specific your data nodes to specific Kubernetes nodes, and that gives you a certain level of both performance and reliability. Or performance, but from a reliability point of view, if one of those nodes goes down, you've lost that data, so you have to then go through pull it back up from some sort of backup. Yeah, so using persistent volumes backed by block storage like EBS or Cinder. So distributed file systems like Gluster or NFS are, yeah, they don't work a lot of times for databases. It really is a different beast altogether. There are solutions in the storage space that actually play at different levels here. The way that this type of thing tends to work at Google is that the difference between sort of a backup and the running state ends up being much more mixed at Google. And so Google has something that's analogous to an object store these days called Colossus. If you look at something like Bigtable, it knows how to use local disk as a cache, but anytime when it's saving data, it's writing it out to Colossus and then reading it back in. And so there is not a lot of there is no non-replicated data sitting on local disk. Okay. Yeah, so Steve says, same image, but different environment variables for the role. And Steve says that the data in the master are also backed by the persistent volumes by stateful sets, but the clients aren't. So yeah. And then Ryan says client nodes have two advantages: a smaller subset of nodes that get the public app traffic connection, so that data nodes can be increased and decreased at will. Okay, so it's essentially become sort of an interface layer. And then number two is the search aggregation of results from the data nodes can be memory intensive, and so you want to isolate that onto a machine. I would be interested, Ryan, if now that we have this idea of a sidecar pattern, of whether it makes sense to think about running a client node as a sidecar that gets paired one-to-one with a worker, and what that starts to look like too. What happens if you actually sort of move that from being a middle box to something that gets co-located with your workload. And Steve says, adding logic for watching cluster state is on the table, just need to hack on it. Yeah. And then Nicholas says, I see it uses cron jobs. Does that mean it's compatible starting with 1.8? I don't know how it uses cron jobs. We'll have to see that. And then Enrique says, looking forward to CSI as well in 110 for shared local storage. So CSI is the common storage infrastructure. It's an evolution of this thing called flex volumes, I believe, which is this idea that we want to be able to provide pluggable volume implementations for Kubernetes. And I think that once those things get nailed down, there's going to be a ton of people doing interesting stuff on the storage side. Q says, we are using rolling indexes, and it's a bit difficult to parse how I snapshot those rolling indexes after the screen share. Going to work on it some more. Okay. Yeah. Okay. So this thing is going on here. It does the data node replicas, the host network. Okay, so one of the things that this thing is it's multi-zone aware from the get-go, and so you tell it the zones that you want it to spread across, and then it makes sure that it creates the PVs in those zones, and then schedules the stateful sets on a per zonal basis also. Now, the cluster that we're using has a single zone, so there's that question. I looked at the code, and there's you can leave this blank. When you leave this blank, it uses default provisioner stuff, which should work, I think, but I'm not sure how off the rails we want to go. So what I'm going to do is I'm going to just go through. I forget which zone I actually launched this thing on. We're not going to tempt fate here. And if I look at my cluster here, the parameters, what did we do? We did US West 2B. So 2B or not 2B, East or West. The cron jobs are for snapshots. Older versions of operator support TPR and PET sets. So those are older versions of stateful sets and CRDs. So Steve's saying I would add the zone that you're in today. Yeah, we're not going to tempt fate. The data volume size is 10 gig. Java options, YOLO 512 meg. So these are going to be relatively small nodes. And then we're going to turn off the snapshot scheduler by default. And then there's this Elasticsearch cron that I guess drives the snapshots. But this is off by default because of the authentication issues to S3 that we'll try and dig into if we have time. This is the storage class and the provisioner that we have going on here. And so what you have here is if we do kube control describe, what is it? We have persistent volume auto, what is it? Cluster. What are the provisioners? It's like classes, right? Storage classes. Okay. Kube control get. So what we have is we have a storage class called GP2. And the provisioner, this is the piece of code that knows how to do that. If we go through, and this is by default with the Kubernetes Quick Start cluster, and pretty much anytime when you're going to create a cluster that has integration with a cloud provider, this is essentially describing some sort of like the parameters for how you create a PV and some of the parameters that go into that. If we look at this, what we'll see is that the only parameter here is type GP2. So both the name of this thing is GP2, and then there's this type in here called GP2, and then there's the provisioner that goes along with it. And so that's what makes up a storage class. The rest of this is just metadata gobbledygook. Oh, and then reclaim policy delete, which means that if you go ahead and when you release one of these persistent volume, it'll go through and then delete it with the storage provider. And then there's a way to mark, yeah, and so there's an annotation here that says that this is the default storage class. So what Steve was saying happens is that the Elasticsearch operator will then actually expand the set of storage classes here to include a storage class and also specify the zone that this thing should be launched in, so that you can have a storage class per zone. And so the parameter there was this type here, and I assume that it will not set it to default in any way. Some of these shenanigans are necessary to deal with multi-zonal issues. Yeah. Yeah, so Steve says, we'll create its own storage classes. You could turn off zones and pass the storage class in, and it would work also. Okay, but we're not going to do that because I don't want to get into the weeds. But I brought this up as an example of what a storage class looks like so that we can figure out. So this type here is what it's going to use for here when it goes through and creates those storage classes. And similarly, the provisioner here is what it's going to use here. So these things are going to look a lot like the default ones that we have. All right, and then each of these things is going to be using half a CPU and half a gig of RAM, and then it's going to have a limit of 1 gig of RAM and 1 CPU. I did a whole episode on requests and limits. If you don't want something, if you want something to be as stable as possible, especially when you start moving towards a highly loaded cluster, you generally want to make sure that at least for memory, the amount of memory you request and your limit actually maintain the same, because then you won't end up in a situation where memory is overcommitted and you start drifting up above your requests, and then you get killed because there's not enough RAM on that box. And so and this starts looking at the quality of service classes also. So Q says the Java options weren't working for me out of the Elasticsearch base. I had to add it as an environment variable to get it to pick up. Interesting to see you have that working. So I don't know, we can look at the deployments that end up getting created and see what happens. Okay, so I think this thing out the gate looks good. Let's go ahead and create it. Kube control apply -f. This is example escluster.yaml, and we'll just do this into the default namespace, and you can see that the type, this is the type, and this is the name of the object is created. And now I can do kube control get, and I think I can do the whole thing, but I can also just do Elasticsearch clusters. And there we can see our cluster, and if we do YAML, we can see that there's, that spec is there. I don't know, I don't see any status Does the operator write status in? Do you know that, if that's the case, Steve? So Steve says, need to also give a shout out to Paulo Perez, who did much of the work for Elastic on Kubernetes to start with. Yeah, he is at Mesosphere now, working on some of the Kubernetes on Mesosphere stuff, I think. Okay, so no status, so it's not writing status out. That's another thing that operators can do, is they can get feedback to users just like Kubernetes does by writing status into these. And there's some subtleties in terms of when you have multiple actors in terms of writing status. But yeah, so that's not something though that that this does yet. Okay, so I can do kube control get pods. Oh, look at that, we got a whole bunch of stuff coming up here. It says container creating. So things are coming up. It looks like everything got scheduled, so we had enough space on our cluster for sure. And then we can get deploy, let's see, stateful sets. SSS state. All right, so we have a stateful set for the data, and we have a stateful set for the master. Our third data thing is coming up. Kube control get PVs. We can see that these things are all 1, 2, 3, 4, 5. They're all created and bound. So that means that our cloud provider is working correctly. So one thing that I think I want folks to be aware of is that if you're bringing up a cluster to test stuff out, like I do for the TGI case here, and then it goes ahead and it creates cloud resources, whether it be EBS volumes or ELB. Instances or the equivalent in whatever cloud you're running in. Typically, what you want to do is you want to make sure that you clean up inside the cluster so those things get deleted before you delete your cluster. Because if you then go through and delete your cluster using whatever sort of provisioner or method you use, it doesn't necessarily know about the volumes that you created or all the other sort of bits and bobs of cloud configuration that you had to create. And so so something to keep in mind there. Otherwise, you're stuck sort of trying to clean these things out manually from your cloud account. I think this is one thing that is nice about Azure is it has this idea called resource sets. And so by default, if you're running a cluster in a resource set, I believe any sort of other objects that you create that are part of that cluster are also created in the same resource group. And then if you delete the resource group, it just sort of cleans everything up. So it ends up being a more nimble version of like the GCP project in some ways. And there really is nothing similar. I mean, there's tags in AWS, but it's not quite the same type of thing. And Q says that cleanup is tricky. Yeah, and even with Helm, sometimes things don't get caught. Okay. Let's see. And then Bismarck's saying some of the short names are not working with the new version of kube control. I just try stuff and see if it works, but it's stateful set. Oh, STS is the one. Kube control get STS. Okay, that one's working. So SSS and SS were not the right shortcuts. And now they look like they're up. I can also look at deployments. And so we have a deployment for Cerebro, we have one for Kibana, and then we have a deployment for the clients. Let's see, volume group from LVM. Are you thinking the resource group stuff? Yeah. I'm not sure. I'm not sure where it came from. There's it is one of the nice things I think though about Azure. Okay. So theoretically, we have an Elasticsearch cluster now. Let's try and confirm that. So here's a bunch. So there's a Helm chart for it too. We did launch Kibana and Cerebro. There's resize, blah, 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 AWS setup, accessing the cluster. So we can go ahead and do that. And the cluster can be accessed internally with Elasticsearch. So we have a service. The service is called... let's see, it's not called Elasticsearch. service host, but Elasticsearch plus as defined in Elasticsearch cluster. So this will be so this is the service that we're talking about here. Okay, and you can see that it's using port 9200, which I believe is what the client port for Elasticsearch. So we can go through and I think we can do kube control port forward. And this is the CTL forward. This is the cool stuff I'm talking about. We can do service and then the name of this thing. And then 9200, 9200. If we do that, then it forward. What this does now, and this is a kube control 110 feature, is it looks at service. Out from service, it digs the selector. It uses that to find a pod, and then it picks one of those pods and actually goes ahead and forwards to it. So it doesn't actually do like the load balancing stuff across the service. It's still going to pick one and only one pod and stick to that. But instead of having to actually go through and find the right pod and copy and paste and do all that rigmarole, with the 110 version of kube control, you can do this directly. Yeah, freaking finally, I'm on the same. And this is something that perfect is the enemy of good, because I had these plans of wow, if I get time, I can write a bunch of code and I can do this really cool proxying thing. And a couple episodes I found that the PR. I don't remember the name of the person who did that PR, but this is very much like, hey, let's actually make this scenario a lot easier. So I'm super happy about this. But now if I do localhost 9200, what happens when you actually hit this? Oh, and it says I have to do HTTPS. Let's try that. And it's going to tell me it's unsafe, and we say YOLO, and there we go. Boom. We have an Elasticsearch cluster, and there's a cluster unique ID. There's a cluster name. We get all sorts of versions and stuff. Oh, tagline, for search. I think that is a reference to the Hudsucker proxy, which was this movie from God knows when, where it was Tim Robbins, right? It was for kids. I love that quote. All right. So we have an Elasticsearch cluster, but Elasticsearch is API driven. So there is no fancy schmancy thing going on here. So Steve says it's TLS everywhere out of the box, and then the certs are stored as secrets. And I think it's great that there's TLS out of the box, and the certs, at least the certs are there. Storing them as secrets is a Kubernetes secrets are not as secret as I think anybody would like them to be. The RBAC model, especially with things like operators, is not as sophisticated. I'm going to be interested to see systems like this as we get container identity, as we get things like Spiffy and Spire up and running, how this type of thing actually evolves, because then you won't even have to create certs. You can reuse certs that are already built into the system. Maybe. I don't know. We'll see. So I think it's a good scenario. All right, so we're able to connect to that, and there's how to run the thing locally. We're not going to do that. Okay, so let's do something. What can we do with Elasticsearch? What is something cool to do with it? So kube control get services. We can hit up the Cerebro stuff, and that's on port 80. I thought you said everything was TLS here, Steve. I don't know. Let's see. So kube control port forward. And you have to use the slash syntax with the port forward stuff, just as a backward compatibility thing. So now if I do localhost 8080, oh, look at that. We're at Cerebro. Boom. Q says we might have, but it's there's part of the base ES image. Never realized they were separate, really. So Nicholas says, is there a way to leverage HashiCorp Vault for the certificate without rewriting the operator? So Sen says, tell us the IP and you guys can index some stuff. No, this is not exposed to the internet, first off. I learned my lesson back in the day. So Nicholas, so that's a really interesting question. So I think there's, when we look at Vault, in context like this, there's a couple, Vault does a bunch of different things. What you could do is actually use Vault, and there's work ongoing to use Vault as a secret storage provider. So that Vault actually is the one storing the secrets instead of having the secrets be stored in etcd for the Kubernetes cluster. There was work ongoing to actually lock down where and how you can view those secrets. So I believe there's some thinking in terms of like, you can say, hey, this pod can use this secret, but what you can't do is actually read the value of the secret out from Kubernetes. That ends up getting stored in Vault. Vault can also play the role of a API-driven certificate authority. The amount of flexibility, at least last I looked, with respect to the options for the Vault-based CA is relatively limited. Most of the time when folks are creating and issuing stuff in an API-driven stuff, they'll end up using the CFSSL stuff to be able to do that, which is the Cloudflare stuff. One of the projects that I've been involved in for a long time is this thing called, and then there's the question of like, okay, let's say that you use Vault to generate certificates. How do you distribute those certificates to the workloads, right? Because you need to communicate that stuff over, or have those workloads generate their own key pairs and have a certificate signed. That distribution problem of I have an identity that I want to give to somebody, how do I establish that bidirectional trust and get them some cryptographically strong proof of identity? That's a problem that Vault doesn't actually solve. And Kubernetes doesn't solve it outside of secrets in a great way right now either. And that's the purpose of this project that I've been involved with for a while called Spiffy. Which is, it's not about creating the certificates, it's about how do you distribute those things in a trusted and secure way. And that's really the hard part of that problem. And so at the end of the day, even if you did use Vault these days to actually generate your certificates and your key pairs, you'd still be in a position where you had to use, you had to distribute those with secrets. Or you'd have to like rely on something like network IPs to authenticate things so that you could actually then automatically approve the certificate requests. It's kind of a mess right now, but there are some longer term projects to try and prove how this stuff works. All right, so you can load some sample data from Elasticsearch website and then do a search on it. Yeah, let's try and do that. And then what are the advantages of using the operator? So I think one of the advantages is that we can scale this cluster up and down very easily by just mucking with that CRD. It can bind in extra capabilities like the backups that we haven't gotten to yet. Yeah, and self-healing, that type of thing. And then Ryan says it's also important to consider whether you really need or require TLS between the ES nodes. For most people, it's not needed or required. Yeah, so Ryan, I guess this is a question. It's like, I think for reading, it's one thing, but I mean, there's, like, I would still be worried as far as the defense in depth in terms of giving things write access to my Elasticsearch cluster. Even if I'm doing something as simple as as sort of a product index database for a product catalog, there may be a case where people store HTML directly in those documents, they get rendered out. And so there might be room, if somebody gets write access to your Elasticsearch cluster, for them to go ahead and use that as an attack vector to do script injection that then goes ahead and steals cookies, and then all of a sudden your admin interface ends up getting compromised. And so that's the type of thing that I would worry about, even if it's something benign like a product database catalog. But there's a cost that comes along with that in terms of complexity. To treat apps like CRDs, clever. Okay, so it's a paid feature of ES2. What is a paid feature? Is the TLS stuff a paid feature? So, and then we're going to look at, and then Juan says, so if we do elastic.com/guy.n.kibana.current.tutorial load dataset.html. What are the chances that this works? Is it co? It really is co, not com, huh? The API that the app communicates to ES would still be TLS SSL. The TLS between nodes apparently is a paid feature. Search guard for TLS, which is why we're custom images since it's open source. All right, so apparently the TLS stuff is layered on outside of the official built-in Elasticsearch stuff is what I'm seeing here. All right, so Ryan says he wants to make sure that clear that the TLS and the SSL of the Elasticsearch API is separate from the TLS and encryption between the nodes. And then paid features mainly the plugin XPack about security. So you've gone way past my knowledge of how Elasticsearch works. But let's go ahead and actually pull some stuff down. So we have let's see, following data sets. So we have Shakespeare. So let's go ahead and we'll do curl Shakespeare. We're gonna, oh no, I don't want to do that. -lo. So we're going to download some Shakespeare. We're going to download accounts.zip. This is taking its sweet time, 87%. Oh, not that. Copy link address, curl-lo. All right, and then I have problems with XPacks because with things like logs-xpack security does a DNS check once and holds the IP address, which causes problems for me with the service address. Okay, yeah, just not re-resolving DNS is a classic Java gotcha. I don't know if it's a Java thing or not, but by default, the DNS client of Java does not re-resolve, does not respect TTLs. You can fix that. This is one of the reasons why folks tend to steer away from DNS for service discovery and dynamic systems like Kubernetes. And then we have some randomly generated log files. The best kind. All right, we'll download those. Okay, those are relatively small. Unzip accounts. So we have an accounts.json and then unzip logs. Wait, what did this thing? Do we have unzip logs.jsonl? Why is this? End of central directory signature not found. Cannot find zip file. What am I doing wrong? G-unzip. Oh, it's G. Just to use all the different ways of doing this stuff. Yeah. All right. So now we have some data. Let's see what this looks like. And it looks like the let's see, let me close this and I'll do open code in the right directory. And what do we got here? We got logs.jsonl. So JSON-L is a format where each line is a JSON document. So it's not one big JSON file. It's essentially a bunch of concatenated JSON files. Shakespeare is something similar where each of these things is, so we have this index and then there's a type. So I don't quite understand everything that's going. So there's like a line. All right, we're going to have to look as we go through this stuff. And then the logs, again, we have the index thing. So I believe that these are probably work in pairs where this is metadata and then this is the data itself. And then we have accounts, and accounts is also JSON-L, but it doesn't call itself JSON-L, so it's not really JSON. Okay, so we're good to go. Okay, Chris is saying it's gunzip, not gunzip. Oh, Chris. Here, we're just going to go Chris. There we go. All right, so we're not going to save that. There's no saving Chris. Okay. All right, so this is not a JSON file, but it's a JSON-L file. Now it turns out, like, I'm going to do a little digression here because this is kind of interesting. When you're dealing with big data, having a record delimited format is actually a relatively subtle and hard problem. And the reason being is that a lot of times what you want to do is you want to say, hey, I want to take this data file and I want to split it up so I can actually process it in parallel. Because a lot of times, let's say that you had like, a 1 terabyte file, well, maybe you want to like break that into like, 100 chunks and upload it to a distributed system so that you can start doing it. So now the question is how do you take that file and break it into 100 chunks, right? One of the things that you could do is you could go through and just randomly break it based on byte boundaries, but now you're going to have records that are split across these chunks, and that's no good because that means that those records will be viewed as corruption when they're dealt with by the individual processors. And so there's these binary formats, and so there's one that's inside of Google called Record.io and some usage of that. But I believe in the Hadoop world, there's like Avro is the format here, where it's essentially a way of like how do we actually take something, break it up, and know that we can actually sort of move it around the boundaries as we break this thing up so that we land on record boundaries. And it's a relatively subtle encoding problem going on there. If you do something relatively naive, like say, hey, I'm doing JSON, I'm going to break it on new lines. Well, what happens when you have that thing quoted, right? Because you might have that the new line is you have a string and the new line is quoted inside the string depending on how you do your encodings, and that can cause you problems. In this particular case, I'm suspecting that these are actually paired records, right? So we can't just do it based on new lines. We have to do it on like even new lines as we're doing stuff. So yeah, so there's a lot of subtle issues in terms of how you encode these big data sets when you want to process them in parallel. Yeah, so Q says haven't used any Avro, but a project just started towards it. Yeah. And then Xavier is saying that there's the network address cache TTL. That's the tunable for actually sort of saying, hey, you should, Java should expire its DNS cache. All right, so I'm done with that digression here. All right, so here we have, this is the schema that we're dealing with. So let's do Shakespeare. Shakespeare and searching Shakespeare is the canonical new employee orientation at Google. So this is what we're going to be looking at. So there's the line ID, there's the play name, there's the speech number, the line number, the speaker, and then the text that's actually being done. So, and then the logs has a bunch of sort of random geo coordinates. All right, so before we load the Shakespeare and logs data sets, we need to set up a mappings for the fields. Mappings divides the documents in the index into logical groups and specifies the field's characteristics, such as the field searchability and whether or not it's tokenized or broken up. So this is essentially teaching Elasticsearch about the schema for Shakespeare. And so I have. Okay, so it said copy as curl. I don't know, what is the, console, I don't know. Oh, wow, install Kibana. I have no idea what's going on here. What is that? Oh, this will actually then skyhook it over to Kibana. Let's see if we can get connected to Kibana. Maybe we can make this work. Cube control get service, it'll all be. And I'm not super familiar with the difference between Kibana and Cerebro, to be honest. I don't feel like I have a good handle on sort of like the differences between those. Okay, you can run the curl commands in Kibana. Kibana has a console, makes it way easier to use. Okay, so let's try and do that. Port forward to service this 808080. So we'll do that. We'll come back here. Now we're, it's saying connect. Uh-oh. So I have to do it. Oh, so I have to be HTTPS to Kibana. All right, so this is pretty. So I was talking, you know, the TV show Silicon Valley. I think this is Ryan's story. Hopefully, I don't ruin it for him. He was saying that there was a point where they wanted to actually show a Kibana screenshot, but they wanted to make sure it was highly accurate. So they went and talked to Elastic, and they wanted to make sure that not only did they get Kibana, but it was like the version that was probably going to be current when that particular episode of Silicon Valley was actually aired. So every time now I see Kibana, I think of that story from Ryan. Okay, so where were we? Here we are. Okay, so there we go. Okay, so I can do, if I do this, what happens? I can, so 5601, I don't want to do, all right, no, I do, this be 8080, right? No, I do that. Let's see what happens if I do this. Save. And now, I'm not quite sure. Go to Dev Tools. Or it was Mr. Robot, not Silicon Valley. Yeah, the Silicon Valley people are not worried about accuracy at all. Okay, so I go to Dev Tools. And there's a console here. And I just, okay, do I copy and paste this then? So it says put this in the terminal. That's not right. I don't put that in the terminal. And this thing is, let's see, why is this? Okay, it's mad because I had it all zoomed in. Okay. Get to work. All right, so we're going to do that. And then I hit play. And boom, okay, we have that thing up and running. Okay, boom. That is the terminal, the console terminal. I'm sorry, if you say console, I think bash. Well, it says bash. Use the following command in a terminal. I'm pretty sure if I put this into bash, bad things would happen. But if I do copy as curl, what does that actually do then? Oh, there's the curl version of it that's doing localhost 9200. Okay, so that's hitting Elasticsearch directly, which would also work for us. Okay, so don't save. All right, the mapping specifies the following qualities. Because speaker and plain name fields are keyword fields, they are not analyzed. The strings are treated as a single unit, even if they contain multiple words. So they're not tokenized. Line ID and speech numbers are integers. And then the logs data, okay, so this is log stash stuff. We're not going to do all that. We'll just do Shakespeare. All right, and this says, this will work. This will be awesome. Okay, so... geez, I'm gonna see the Kibana thing. I'm gonna run up here also in the background. So we got both of those port forwards running, and then this line. This is gonna load. Oh, it says empty reply from server. What does that mean? Should be able to just click the view and console link now that you set the default console URL. Deploy the operator, try to, okay, so yeah, so did that work? Create index, visualize, dashboard. No, that's not what I want. So index pen, did it not work? I don't know if it worked or not. Oh, HTTPS. We need to do the HTTPS. Ah, gotcha. Oh, and then I need to do, then we need to YOLO it. Okay. Seriously, if I had a program like curl and I said insecure, I would have -- YOLO. It would be a combination of say yes to everything and turn off all the security. And yeah, and would probably have a really cool banner that it showed when you used it. All right, so this thing is uploading. Now, how big was this? Was Shakespeare? So we're talking, oh, that's 25 megabytes that we're putting up there. Yeah, PR for Kube Control. Oh, the other thing, we do need to make Kube Control fabulous. We definitely need to lolcats Kube Control. We got to get on that. All right, so this is, so there should be something happening now, right? Do I have to create, okay, so it didn't have me verify successful loading by looking at indices. So do we create the index? That's all that. Do you have to specify, or does it just, you just assume that you're getting, when you map these things, it automatically creates the right indices, I assume? Because we're putting a mapping in here. Can we go through and actually, if I look, can I look at what are my mappings? So I don't see anything in Kibana called mappings, which kind of confuses me. No default. Okay, so I do have an index pattern called Shakespeare. So I don't know. Yeah, so this is me being a total noob when it comes to this stuff. So if I do that, the index pattern doesn't match any indices. You can match one of your, so this is what I want to do. Shakespeare, there we go, boom. Next step, time filter. I don't want to time. Go to existing. Okay, and so you can go through and work on these, and we have type entry and all that. And then I can just do, okay, and here we have, here's all the, so now I can go through and I can do speaker, King Henry. No need to yell it, dude. Okay, yeah, and you can start filtering on this stuff. And then I can do, let's see, speech number 1. And that filters that, right? If I spelled speech wrong, it would work. Do I have to do an and? Huh. All right, but we can do, okay, so twitter.com/ let's see. All right, so this particular Twitter account, no, this is not the right Twitter account. So I don't want to out who this is, but this particular Twitter account is somebody in my family. And so, so William Shakespeare follows me on Twitter, which I'm very proud of, and definitely has more. Okay, so the table's full. Let's see if we can figure out. So this is the William Shakespeare thing, and we're going to search for the table's full. Oh, no results found. Maybe there's no period. There we go. No, but that the table's full. All right, so apparently maybe it filtered. Oh, it probably, as part of the pre-processing of this thing, it probably filters out the, punctuation, I'm guessing. So yeah. Okay, so that is from Macbeth speech 19, line number 3.4.54. I don't know what that means, but that's probably like different. And it's Macbeth saying that. Boom. All right. Very appropriate when you're searching a database to use a quote of the table's full. Let's see if Shakespeare has any other good database quotes for us. I will frown as I pass by and let them take it as they list. Let's see where that's from. Boom, first one. Romeo and Juliet, it's Gregory who's saying it. So there you go. Yeah, so my family member that runs this Twitter account, he likes being snarky and coming up with Shakespeare quotes for every occasion. So there you go. Oh, yeah. I wonder what he's subtweeting about. All right. So, I think, this is at least enough to get started with. I think, the next step would be like, what are you going to use Elasticsearch for, right? Are you going to use it for a product? Are you going to use it for log ingestion? I think, there's probably plenty of documentation on the Elastic site going into those details, and that's definitely not what I'm looking at here. I think one of the interesting things I learned is that the TLS stuff is something that's built on the outside on top of this stuff. I think it's a little bit weird that TLS is a pay-for feature. I think security should be something that's built in by default. It is interesting also to me that there's TLS, but there's no, which secures the channel, but there's no authentication, right? So how do you authenticate yourself to this thing? There's no authorization models. That's something that if I were going to start using this, in depth, I'd be looking at. Let's kill some pods and see some recovery action. Okay, so the first thing is, so view single dot. So the first thing, this is my question for you. So a couple things I want to do. Let's do that. Let's try and like beat this thing up a little bit. And then Ryan, is there a way to know? So the way that Elasticsearch works is that it takes each document, it assigns it to a shard. That shard gets assigned to a data node, and there may be replicas, so you may have the same shard be replicated across multiple data nodes. Is there a way to, Enrique says that authentication and authorization is built in to the XPack stuff, and it's something that can be layered on. Okay, so that's good to know also. Is there a way for me to say, hey, for this document ID, which I guess is this thing here, for this document ID, is there a way to figure out which particular node this thing landed on top of? Because then I want to make sure that I take out the node that, that actually contains something that we're looking at. Okay, so the default number of replicas is 1. Okay, so if we take out that node, then we should be able to do a query, and it'll return partial results, I assume, that don't include the stuff that's on that node. And then as that node spins back up, and EBS magic happens, as that data node spins back up, we should see that the results start to populate with that thing. So I'm wondering, how can I figure out which node this thing actually gets, which data node this thing actually gets assigned to? Saved objects? No. Advanced settings? Maybe this is something that Cerebro can do? The cat API. All right, you're going to have to help me out, man. I'm going to need more than that. There's the mapping API. Cat. So get cat in the Kibana console. That would be in dev tools. Get cat. Oh, okay. And then we can look at nodes. Do we want to do that? All right, so this is, I think there's our masters. This is leader election. These are data nodes and index nodes, I'm guessing. Something like that. Get cat. It will self-explain from there. You have a lot of confidence in my abilities, Ryan. Okay, so get snapshots, indices, shards. Okay, so we can do get cat shards. And then there's Shakespeare, so we can look at the shards. Started, there's a GUID. I don't know what I actually do next. Is it the, do I do that? Oh, sorry. Add V to the end of those lines, okay. It doesn't like the V. We'll add a header line. Okay, so we have segments, indices, tests, so shards, segments, recovery, blah, 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 blah. Okay, so we'll do shards, All right, so shard, primary replica. Those are primary and read replicas. Okay, so this is actually replicated. The number of replicas is higher than one here. The number of docs, the size of it, the IP that it landed on. But this still doesn't tell me. Yeah, no, the delay sucks here. I mean, this is one of the bad things about YouTube. It still doesn't tell me what document this thing, like if I go through, I want to figure out which shard, which node a particular document is on. So field data, no attributes, blah, blah, blah. So if I do, that's like, give me help. What do I got? Cluster. I can do all of this, cat, cluster, count, fields, data, mapping. Get Shakespeare search. Okay, so we'll do that. And then how do I do this search here? Search. And then, see, I'm trying to figure this stuff out. Oh, it doesn't like it there. So one of these things, so here's the source. We can get the doc ID. So I know the doc ID. I want to decode doc ID to node. Let's see. Yeah, I think I'm in the weeds here. Is it possible to find which electrified document is on? Oh, so we could. In your query, you can enable the explain flag, which will tell you where each of the documents are from, which node. Oh, there we go. So that's what we want. We want the explain flag. I wonder if I can do this here. Add a filter. Explain now. Okay, so I can do, there we go. Okay, so that's what we want. So this thing is doc 85334. I can go to Dev Tools. I can do doc. So if I do that, that should give me the doc, right? And then I do underscore explain. Okay. What are the chances this will work? Query is missing. What am I doing? Twitter doc 0. We'll use the doc without the underscore. Well, this one does have the underscore, but let's try. No. I'm just flailing here. Copy that JSON, put it immediately following the URL command line. Oh, I see. Ah, I get you. This is actually not the return. All right, so I feel like we are totally in the weeds here. So Elasticsearch uses get with a body. Okay, So this says, okay, so the ID, but okay, so this got it, but the explain thing didn't work. What's going on? It said it should do message, match. Oh, and then I just don't want any match, I guess, huh? There, no text. So that's not it either. All right, so I'm not gonna try and chase this down. This is me not being an expert here. Remove the match query syntax. Okay, so just do that. There we go. No, illegal argument, failed to parse. It's still mad at me. The underscore, unexplained. No handler, maybe on the doc. Failed to parse. I don't know what I'm doing, man. All right, so, all right, but regardless, okay, let's go through and we're just gonna, like, we're gonna go through here and we can go ahead and we can do this search. Let's see. So, okay, so we'll do this search. If I was smarter, I would know how to actually sort of do this in a loop so that we could actually see things sort of failing and stuff. But let's go through and kube control, get nodes, or get pods, and let's take out one of the data. Kube control, delete pod, this. Kube control, get pods. We'll watch. So it's still working. It's terminating that pod. So it's trying to do a smart, oh. And we're still working as this thing is up and running. And then it's creating a replacement as we did this. So we're actually in decent shape here. Explain true is the first line of the JSON. Oh, so you can do that too. Okay. So we can do I don't know what's going on. Okay. All right, and so then we're back up and running. And now if we go through and if we look at management, how can we, or I guess we can do dev tools. We can do get nodes. And we can see here's our cluster, and there's all sorts of metadata about this. I wonder what is cat nodes. We'll do that. There we go. All right, cool. And so this thing is up and running. Now so it identifies the name of the node. Get pods dash. If we do this, then we actually get the name of this thing is the data guy here that we killed is 134. 134 is now here again. So we actually do have 134 has been created. So cool. The cluster became yellow and not all shards. Where do I see get cluster health? Okay, let's try that. Why that? Didn't like that. All right, there we go. Number of nodes, number of data nodes, number of primary shards, active shards, status green. Okay. So now let's go ahead and let's kill this thing again. And we'll wait. And oh, so now it's yellow because it's actually underscore cluster health. Yeah, YouTube's not our friend here. Like the YouTube comments. All right, so we're like way over here. So I wanted to go into some detail real quick about the snapshotting stuff. So the way that Steve wrote the snapshotting stuff originally is that he uses the native API for AWS, where it gets credentials to talk to S3 by talking to the AWS metadata server. And a lot of folks run Kubernetes clusters on AWS, and they allow access from pods to that metadata server, which is not an insane thing to do if you are running sort of a single application cluster. But most people, and if you read guides on sort of like how to secure a Kubernetes cluster, what you want to do is you don't want to give every pod access to that metadata server and therefore access to whichever other AWS services that are available via that metadata server. And so, the AWS Quick Start that we are, oh, it's back to green here. So the AWS Quick Start that Heptio did, we actually installed some IP table rules to actually prevent pods from getting to the API, to the metadata API, and hence the ability to then call through and talk to AWS services and authenticate to those things in a native way actually gets kneecapped, right? So it gets broken. A popular way to work around this is a project called Kube2IAM, which essentially creates a replacement metadata server on a pod by pod basis, and that is it's a workable solution, but I haven't used it a lot personally. The security model there though is that any permissions you'd want to give any pod you have to give to every node, and then there's a local agent that actually gives out those roles on an as necessary basis. So it's not quite as locked down as I would prefer there. My understanding also is that there's some sort of race conditions there that lead to some holes around sort of, being insecure. So again, this is one of those issues where it really comes down to container identity, very similar to the issue of how do we actually have multiple containers talking to each other in a secure way, these TLS issues. It's another sort of side of that coin. Now there's a working group here called the Container Identity Working Group to start approaching problems like this. And the solution that we're coming up with is to be able to map a one-to-one between, say, Kubernetes service accounts and some role in the cloud. And so and part of doing that is that there's new APIs that I believe made it into 110 so that you can on demand create a JWT, a token for your service account with a custom audience on it, and then give that to some other sort of arbiter that knows how to map that particular thing so you can prove who you are to that particular person, and then they can go ahead and map that to some other identity, whether it be in AWS identity or not. The problem there is that that doesn't get automatic support from all the AWS client libraries that are out there. And nobody's connected the dots to use that transparently with something like a Kube2IAM type of experience. So there's some holes here yet, and it's been on Steve's list to actually add the ability to say, put your S3 credentials in a secret so that the operator can use that. That's just not something that's supported yet. So the only way to talk to S3 is via that metadata API, which, like I said, is disabled by default on the Heptio Quick Start, and probably should be disabled on most clusters running on AWS. All right, and then Q. So I'm going to sign off here soon. It says, is there a decent Slack channel or group to discuss these topics, Elasticsearch with Kubernetes? I'm not sure. Steve might have an answer there. And then finds a rather niche topic, hard to find anybody else that's interested in discussing it. Well, Ryan and Steve have some experience there, so there you go. All right, so I've gone way over. I feel like I've been a little bit less driven this time here, so I haven't sort of been on the ball here. But I want to thank everybody for joining me here. Hopefully, we learned some new stuff, did some interesting digressions. Thank you to Steve and Ryan, big time for staying on the line and giving us some advice here. It's always I always learn stuff, and I love learning stuff from the experts. So that's really, really great. And so it looks like Julian and Juan also would love to learn more about running Elasticsearch on top of Kubernetes. So hopefully you all can get yourself hooked up. You can reach out to Steve on Twitter. He's Steve Sloka everywhere. That's probably a great way to start seeing if there's a format, someplace to actually start talking about this stuff. And I also, in my tweets, for this particular episode, I tagged him too, so you should be able to find him that way. All right, and thank you everybody for joining me. Have a great weekend if your weekend hasn't already started. And if you're going to be around at Kubecon next week, definitely come by the booth and say hi. And we're trying to have some good swag, some good stickers and stuff there. So hopefully I'll see you there. All right. Everybody have a good weekend.